transformations to this point. Again, I said I learned as I taught this many moons ago. I did it based on doing an order in which I did this. So, for example, what I would do is if I had y equals a sine b x minus c, and the only reason I'm telling you this is it may be easier for you to do it in the way I did it. So what I would do is this. The first thing I did is I drew a line. Okay. And on that line, I started with C. So the first thing I did was my C. So I would mark my C in here. Then the second thing I would do is mark my other 5 points. Now, because it's a sine graph, I would just draw 5 points on this line. Okay. Now, this is going to be confusing to start with. So then the next thing I would get is B, because that value right there is C plus B. So C is your phase shift to your left or right. That's how much I move the sine graph left or right. So that's the first thing that I would identify. Then my last coordinate, so I just draw my line like this. My last coordinate would be C plus B, because B is your period. So that's how long it would take. All right? Then the third thing I would do is mark in my D right there. So I'd mark in my D because that's the midline. That's the equilibrium position. That's where the graph moves up or down. And then I would mark my maximum min next, because this was A plus D and this was D subtract A. Let me just write that. I'll write that as D plus A. So I could do my graph that way, and then the final thing that I would do, so then I would mark in my A. The final thing I would do is my axes. And like I said, I'm going to show you how this works after. But then I would mark it in, and depending on where everything is, my axis might be this and it might be this. So it's all dependent on where all of those are. So that's the order in which I would do that. So this is how I used to teach this course. All right. I believe now, because you did the first unit on transformations, the second unit was on transformations of square root functions, the third unit was transformations of polynomial functions, I believe that it's easier to keep it consistent and do it that way. So take the 5 key points of the sine or the cos graph and move them. But I'm going to show you both methods today. Okay? So first things first. I'm going to take a graph that's a little more complicated than what I have here. All right. And I'm going to use, for this particular question, I'm going to use degrees for it. I'll get to radians in a minute, but degrees will be easier to use right now. All right, so I'm on page 162, and here's the equation. Okay, so my 5 key points. My 5 key points are for the sine graph are here, 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 and here. Okay? That's what my 5 key points are. So this part of the graph right here represents your x axis is actually your degrees, your radians. Or sorry, not your radians, your angle. Okay? So this coordinate here is 0 and 0, right? What's this coordinate right here?
45.
Not 45.
90 and
Yeah.
1.
Yeah. Good. 90 and 1. Then this one is 180 degrees and 0. Then right here is
270 and -1.
And then here?
360.
Perfect, thank you. Okay, everybody make sense of that? So those are your 5 key points for a sinusoidal graph. All right? Good? Okay. So I'm going to use those points right here then. Okay. So first things first, we use our A value, right? So A value is that, agreed? Yep. Okay. So, right, so I have, that stays as 0, 0, correct? This becomes 90 and negative 5. 180 and 0. 270 and 5. 360 and 0. Okay so far? All right. Now I did B next. So what is B?
360 over 1/2.
Right. Okay. So that is 1 over B times X, right? And then that stays as AY. Okay. So what's my B value?
2.
No, my B value is 1/2, but I'm going to multiply all my X's by 2. Agreed. So this is still 0, 0, right? This becomes 180 and negative 5. 360 and 0. 540 and 5. 720 and 0. Is everybody still okay with what we're doing here? Yeah? Okay, again, all stuff that we have done to this point, right? Okay, so now C value, 1 over B, X, add C. Can I fit in? I'm going to do it anyways, whether you like it or not. I'm going to do both of these together, okay? Everybody okay with that? So I got to add 90 to all my X's, so let's start with that. That means 90. That's 270, 450, 630, right? 810. Okay, and then I got to add 15 to these. 15, 10, 15, 20, and 15. Okay, there's my new coordinates that I have to then graph. Are we good so far? Everybody's okay? All right, so let's look at this graph then. So at 90, my new value is 15. Okay, so what I'm going to do, I'm going to shrink this guy. This. Okay, so my sine graph is like this, essentially. So there's 1, there's negative 1, right? Okay, so the first coordinate I have is 90 degrees and 15, right? So that's somewhere up here. 90 and 50, I'm going to just drop it down a bit. Right there. So that's 15 right there. Okay? The next coordinate I have is 270 and 10. So here's 270. So it should be about right here. The next coordinate I have is 450 and 15. So this is 360 right here on my new one. So 450 would be somewhere over here. And then I go up here. And then I go down here. And I got this. There's my new sine graph. Where is this located? Right here. Where's the end point right here? 810. And it starts at 90, right? Okay. How do we like that? Right there. Are we okay? Yeah, go ahead.
Why is the midline of the axis like maybe?
My new midline is right here, Avery.
Yeah, but like at the beginning, what like is it always at the axis at the beginning?
Okay, think about a sine graph. All right? And I drew this on the board yesterday with the unit circle. So let's do it like this, okay? All right. At 0 degrees, what's your sine value? 0. At 90 degrees, what's your sine value? At 180 degrees, what's your sine value? 0. At 270, -1, and it goes back to 0 and 0. So 0, 90, 0, -1, 0.
So for the sine lines, it's always the axis.
For sine and cos, both, your midline always is the x-axis. Okay? All right? And that's again because of the unit circle. So when I do this for cos graph, then this is what it looks like. 1, 0, 1. Is that right? No, -1. 0, and back to 1 again. So your cos graph looks like this, Avery. So what's your midline for that guy? It's still the x-axis. Okay? Makes sense?
Yeah.
Now, your new midline is whatever D is. Your new midline is whatever D is. You follow?
Yeah, I understand.
Okay. All right. Now, so is everybody okay with this method of graphing? To me, because you have done it numerous times, I think that's the easiest way for you to do it. Agree? Disagree? Agree? Okay. But I'm going to show you, and again, this is completely up to you how you want to do this. All right? I'm going to show you the next one. All right. So we had what? Y equals -5 sine 1/2 theta minus 90 degrees, right? At 15. That's correct? Okay. So a sine graph. A sine graph has 5 key points and they're all in your midline. So I would draw it like this. Okay? So I mark off those 5 key points. Now, this is just a line. This is the midline, and I have the 5 key points on it. Now, there is an issue with this one because A has a negative value to it. So rather than it going up to your next point, all right, because A is a negative, I actually draw it this way. Like this. Okay. Does everybody understand why I did that? The negative flips the graph over the axis, right? A negative A is what we call a reflection over the x-axis, right? So this in this case, A is -5. So I have to flip it over the negative axis. Are we okay with that? All right. Now, watch what happens here. In the order that I just wrote them out for you, what was my C value? That's the first thing I put. What is it? 90 degrees. Okay, perfect. So that coordinate right, this x value is 90 degrees right here. What's my period for this graph? No.
360 divided by 1.
360, my period is 360 degrees divided by 1/2, which is what? 720. What's 720 plus 90? 810. So that goes right here. Now to label these other guys, all right? So my period was 720, agreed? Yeah? What's half of 720? 360. So I add 360 to 90, that gets me to right here. That gives me that 450, which is halfway between 90 and 810. Now I'm going to add 180 to this. This is 270, and add 180 to this, which makes that, I got to cheat, 630. So there's my 5x values for this graph so far. So what I did is I put C down. I added the period to it to get the last coordinate. And then I fill in these three by taking the halves of the distances. That's what I did. Make sense? Yeah. Okay. Pretty simple, right? Now, I mark off where my midline is. Well, where's my midline?
15.
At 15, because that's my D value, right? Actually, I'm going to do this instead. Sorry. I'm going to do this. Okay? So 90's right there. My y-axis is somewhere over here. And again, this is now considered a sketch. So I'm just going to place it over there somewhere. Because 0 would be right here. My 0 for my x, my 0 for my x would be somewhere over here, because that starts at 90, right? All right, and then this is way above. This is 15 right here, is that not? So my y-axis would be down here somewhere, or sorry, my x-axis would be down there somewhere. Okay? Now I mark off my maximum, my minimum. How high up does it go? 20? How low does it go? 10. Same graph. Same graph. So when you do this question on the exam, they might say, sketch one period of the sine graph of that equation. I just did that. So what I do is I draw the line, I mark off my 5 key coordinates, and then I label that line after, and then I'm done.
So like to show your work, that is just like.
That's all I got right
it?
there. Yeah. The only other thing I might have done, honestly, is done this. I might have done that.
Okay.
But that's it. So if this was a coast graph, well, let's just do one. All right? Let's do a coast graph. Let me find it. Okay, I'm going to do a coast graph with radians. Fair enough? Okay. And again, now I'm going to do it. I'm going to do my coast graph using that method first, and then I'll do the method that you're used to. Okay. And again, this is far. I think this is way quicker, and probably less chance of you making an error on it. But you got to remember how to do the steps properly. Okay? So here's page 164. Y equals 1/2 cos 3 theta plus pi over 2. This is where you're going to hate this method. Actually, you're going to hate both methods for this. All right? But it is what it is. Okay, now it's a coast graph. So I'm going to draw a midline and show my coast graph. So I draw my midline. Coast goes here, down to midline, to my minimum, back to midline, back to maximum. That's my coast graph. You agree? Starts at its maximum, midline, minimum, midline, maximum. That's your coast graph. Do we all remember that, how that looks? Okay, so then it goes like this, there, like that. Okay, once I have that, I start with my C value. So what's my C value here? Actually, you know what? Let's do this. Let's write these out right now. A, B, C, and D. A is, B is, C is, excellent. D is, okay. So I have negative pi over 2 goes right here. All right, what's my period for this graph?
2 pi divided by 3.
Very good. 2 pi over 3. Okay, this is what you're going to hate about this. All right, so I want this coordinate here. How do I get this coordinate here? Or the x value of that coordinate? How do I get that? C plus b, right? So I need negative pi over 2, add 2 pi over 3. What did you say, though? You might be right.
I said pi over 3.
Okay.
But I forgot to change like the
Okay.
to
Negative pi over 2. We're going to do some mental math here. That's negative 3 pi over 6, right? Negative 3 pi over 6. Let me write that down. Negative 3 pi over 6. Agreed? Over 6, what is that? 4 pi over 6. What's negative 3 pi over 6? Add 4 pi over 6. So that's right here. Like that. Okay, so far. Yeah? Okay. Now, we got minus pi over 2 to pi over 6. Now I need to get these 3 coordinates here. Okay? Now, what's half of that value? Pi over 3. Right? The 2 on top cancels the 2 on the bottom. I get pi over 3. Okay? So I'm going to add pi over 3 to that guy to get this part right here. Okay, so what was this? This was 3 pi over 6. Add 2 pi over 6 gives you what? Sorry, negative 3 pi over 6. Add 2 pi over 6.
negative pi over 6.
Negative pi over 6. That's one way to do it. Want to see a different way to do it? Add those two together and divide by 2. I want to get this guy right here, so I need the halfway point between those two. It is. So, Madison, that's my axis right there. Is that 0? Right? Now I need negative pi over 2, add negative pi over 6 divided by 2. So this is negative 3 pi over 6. Add negative pi over 6 is negative 4 pi over 6. Agreed? What is it? Negative pi over 3. Okay. So that's the only part that's difficult because of the fractions. All right. Now, where's my midline? So my midline is at negative 1. What's my amplitude?
1.5.
So that makes this 0.5 up here. And down here, what is it?
Negative 2.5.
Negative 2.5. So where does my x-axis go? Right about there. There's my graph. Again, the axes can be sketched in where they're approximately. Now, if you're doing this on grid paper, sure you would, but I need you just to get to that point. Okay with that? All right? The key, C first, C plus B gets you to your last, and then finish your x-axis off. All right? Then at that point, I might add in my x and y axis, and then I put my midline D in, right? And then use the amplitude to get your max and your min. So in the order, C, B, D, A. That's kind of the order in which you go. All right, let's use now, I guess Reese isn't going to join us. See you, Reese. All right, now, let's do A, B, C, D, and our transformations of the original graph. And see if it's any easier. Okay, what was the equation? Y equals 1.5 cos 3 theta plus pi over 2 minus 1. Okay, x, y. 0, 0 and 1, right? That's where we start our cos graph. Cos graph starts at 0 and 1. Agreed? Now here's it. Now, again, not a huge fan of working with the fractions. So I may decide to change pi over 2 to 90 and use degrees on this, solve it all the way through for degrees, and then change it back to radians after. Follow? Might be easier. But we can try right now. Let's try right now just to work with the fractions. Okay? So my next one is pi over 2 and 0. 1 pi and negative 1. 3 pi over 2 and 0. 2 pi and 1.
So those coordinates will always be the same for like the constant?
Okay, now remember what we started this all with. When we use the square root function, I use 0, 0, 1, 1, 4, 2. Right? This is the cos function. That's my 5 key points for cos. So I'm going to use that. Make sense? Okay? All right. So now, A first. What's my A value? 1.5. So now I go x. Oh, I'm going to do this in color. Make it pretty. X, A, Y. So that's 0, 1.5, pi over 2, 0, pi, negative 1.5, 3 pi over 2, 0, 2 pi, 1.5. Good so far? Okay? B now. 1 over B x, right? 1 over B x, AY. 0, 1.5. Pi over 6, 0. Pi over 3, negative 1.5. This is going to be pi over 2, 0. 2 pi over 3, 1.5. All right, let's do C and D together again. Can we do that? Okay, I have to subtract pi over 2 to all the x values. Minusing pi over 2 to all the x values. So this becomes minus pi over 2. Pi over 6 subtract pi over 2. Pi over, what do you got?
Negative 3 pi over 6. So then pi, negative 2 pi.
Negative pi over 2.
Negative pi over 2.
I think I agree with you. Pi over 6 subtract pi over 2 is pi over 6 subtract 3 pi over 6. Pi over 6 subtract 3 pi over 6 is negative 2 pi over 6. So it's actually negative pi over 3. Would you agree?
Yeah.
Okay. Pi over 3 now, subtract pi over 2, is 2 pi over 6 subtract 3 pi over 6. Negative pi over 6. Pi over 2 subtract pi over 2. Two pi over 3 subtract pi over 2. 4 pi over 6 subtract 3 pi over 6.
Pi over 6.
This actually might be the easier way to do this question. Okay? Now, 1.5 subtract 1. 0.5, negative 1.5, negative 2.5. Oh, what am I doing? Negative 1, correct?
Yeah.
Did I do that?
Same for the second one also.
This should be negative 1 here.
No.
Thank you. Okay. And then right here is 0?
0.5.
Oh, 0.5. Thank you. 0.5. Okay. Now, you got those written down? Do they match up here? Negative pi over 2 and 0.5. Negative pi over 3 and negative 1. Negative pi over 6 and negative 2.5. 0, negative 1, pi over 6 and 0.5. Is that what we had?
Yeah.
Those all match? Okay. That might be the easier way to do it with radians, to be honest with you. And good work on the math. All right? Questions? We're okay? Okay. Let's finish to the end of that for Monday. Then we'll look at the tangent function on Monday. It's the tangent graph. That's Brand doing test Monday. Tuesday we'll do tangent function. Tangent we have not looked at yet at all in terms of graphing. And we only do 2 things with the tangent graph. All you do is stretch it and move it left or right. You don't do A, you don't do D, I think. I think it's pretty straightforward. Okay. Any questions today? Whether you got any questions about your test on Monday? You went through that assignment, you checked it over, you went through your book, made sure you got that under control? No questions at all? Okay.